Thanks, team. It's great to be here. Such an honor to be invited to this forum, and especially because I'm representing a group of people I'm really, really proud of. 16,000 strong of the National Geospatial Intelligence Agency, which we'll call henceforth NGA. What do? Well, for the next 8 minutes, we're going to go over 3 tasks, basically. I'm going to introduce you to NGA. The second task is I'm going to introduce you to something that helps us with the scale and speed of our job, and that's NGA Maven, and by extension, something called Maven Smart System. And then third, we're going to talk about the future and the trajectory of AI and ML at NGA. So here we go. Task 1, NGA. NGA is in charge and is the center of excellence for geospatial intelligence. And what that means is we task, process, exploit, and disseminate understanding and through images. Think imagery, think satellites. We task satellites, and then we take all of that data that comes in and we build understanding with accuracy. And it takes people, but it also takes some advantages of IT, and that's why it's so exciting to be here with you. So before I go into Maven, let me just go into kind of the scale of the situation that we're facing here. We move more ones and zeros. Our throughput as an agency is higher than any other agency. And some people might be surprised to hear that, but then again, you shouldn't be surprised, because if you've ever taken a high-resolution photo with your phone and then you want to send it and you didn't realize you did that and it just chokes, try doing that around the world. Try doing that with a constellation of satellites that is ever growing. It's a good problem to have. So we need an advantage, and we turn to the advantage of artificial intelligence and ML with the advantage of the best of breed and photo interpreters and imagery interpreters at our station. Enter Maven. Let's talk about Maven. This is task 2. NGA Maven, and by extension Maven Smart System, is now a program of record. It began as a project. It was first meant to build excitement within this sector, but also within DoD to see the importance of using AI and ML in imagery interpretation. And it also is the first software to be validated by what we call the Joint Requirements Oversight Council, JROC. So this is the real deal. And sometimes there might be a tension, a healthy tension, between courage, where you want to fail fast, and yet stewardship, because we're dealing with the taxpayers' money. We don't want to pay twice. We will make sure that we're taking the right risks and we're doing it responsibly. You're seeing now a slide loop of some screen captures inherent to NGA Maven and Maven Smart System, the graphical user interface that we use. And it represents one of the things that we do at NGA, which is targeting. We also do warning, we also do safety and navigation. I'll address those in a few minutes. But right now we're going to talk about targeting and the targeting cycle, and the efficiencies and the scale and speed that are brought by NGA Maven and Maven Smart System. Targeting. You see words like OODA loop. It's effectively a business process. It begins with objectives and guidance. It moves into target development. And let's just stop there with target development, which involves how to discover the right targets and ensure that you're accurate in your characterization of those targets. And especially when you're talking about what we call positive identification. This is a presidential prerogative. It is the prerogative of the Secretary of Defense. It is the prerogative of a supported commander, a combatant commander, and as a combat support agency, this is immutable for us. It is so important that we get it right. So in target discovery, when you have all that data coming in and you're going to have the same number of eyes, ultimately, looking at that to ensure that we derive positive identification, it's time to use AI and ML in this graphical user interface known as Maven Smart System. And that's the power of it. So as the data comes in, we have models that have been developed with the assistance of our best-of-breed experts that run inference on all that data and then discover proper targets. They don't render decisions. they actually render a confidence level, a certainty level that helps that supported commander make that decision. It's really important that you understand that this is a tool for decision making. It's not a decision maker. So what's the scale we're talking about here? Why is this so important? A lot of you may have gone through global entry, or you've gone through TSA, takes a quick picture of your face, and you're really impressed by the identity that it is able to establish, and you proceed. I wish it were that easy in our business. That's about 80% of the field of view when you're talking about your face in that particular sensor. Try this from space. Try this now where you're looking for an object or some sort of a behavior that you need to distinguish that is 1/100,000ths of a percent of the field of view. That's the challenge that we have here. And thank goodness we do have our partnership with the commercial sector made manifest in something like Maven Smart System. I don't go into exactly where and how it's being employed in the real world, but I will tell you, you'll find it in operational centers like United States Central Command, United States European Command, United States Indo-PACOM, United States Spacecom, and hopefully many others. And that cycle that we talked about, the targeting cycle, it also has things like force application, force execution, and ultimately combat assessment, and it starts over again. And the code is so agile that we're actually able to add those aspects of the targeting cycle, not just target discovery, and that's very powerful. In the last minute that I have, I want to go over just a few thoughts about the future. So, what's important about targeting could also be important when we're talking about our other missions in warning and the safety of navigation. We intend to take this momentum that we've built with Maven and apply it to a larger construct that is the entirety of warning. This is where you establish a baseline for behaviors and equipment across the world, especially in hotspots where there might be irresponsible things that need to be found. Look for those anomalies. Use the same pairing of machine learning as well as AI to ensure that we are triggered as humans to take a second look. Secondly, the responsible application of this particular code for us is something that is very, very important to me and to our agency. So we've adopted already something called GREAT, GeoInt Responsible AI Training. Anyone who touches the code is going to be certified to understand the principles that we hold dear, things like the laws of armed conflict, things like the principle of distinction, ensuring that we have absolutely derived positive identification, separating combatants from non-combatants, good behaviors from bad behaviors. And then we also have now ventured into an accreditation of models. So when you're dealing with something as important as positive identification, you want to ensure that the model itself is grounded in best practices and good training data. This, for us, is something that we have announced as a pilot called the Accreditation of GeoInt AI Models, A-Game, and it will have gradations, A-Game 1, 2, 3, 4, based on how intense our examination and certification is of the training data, the personnel, and the practices. So, this is very exciting, but we can't do it alone. That's why I'm here, frankly, to address some of the best and brightest of the commercial sector. And I appreciate the fact that you're taking the time to listen as well. This partnership is tantamount to ensuring that we keep America safe and ready. Thanks for listening.